Alright, so problem number 2. So I see 28 inches of mercury and I see vacuum here. What does that tell me? It tells me I got to change that. I can't use 28 inches of mercury vacuum. And that means that, of course, we're up here at atmosphere. Right? So what they're saying is the vacuum is this deep. 28 inches. So we know here it's 0. We go up all the way to the top, atmosphere, that equals 29.94 inches mercury. And that, of course, is inches mercury. So what we need is a back pressure. We need a real pressure. Don't see us ever using the vacuum, so this won't hurt us. I'm going to say pressure of the condenser, the back pressure, is equal to this point, this amount right here. That's the back pressure. All right? And that's going to be equal to 29.94. Excuse me. 94 minus 28, and that is going to be in inches of mercury. And that, of course, is going to equal 1.94 inches of mercury, which is also going to equal 1 psi. All right, I think we've done enough to where I don't have to work that out. But since the purpose of this is to do it the long and dumb way, I'll do it. So condenser back pressure is equal to 1.94 inches of mercury. 29.94 inches of mercury is equal to 1 atmosphere. And 1 atmosphere is equal to, what, 14.7 psia, or 15 if you want. So using our calculators, we're going to get 1.94. It's not plus, it's times 14.7. That's going to be divided by 29.94. So I got 0.95 psia. So I'm going to go ahead and say that that is approximately 1 psia. So for my steam tables, I have noticed that saturation temperature at 1.0 psia is equal to 101.69 degrees Fahrenheit. I haven't even read the problem yet, have I? So think about that. Don't let these things fool you at the beginning of these problems. So I got other numbers here. We got 92 degrees. Got some condensate depression going on. I even read a problem, and I know there's some condensate depression going on. A main condenser operating at 28 inches of mercury vacuum, or 1 pound back pressure, absolute, with a condensate outlet temperature, that means water going out of the condenser, is 92 degrees Fahrenheit. So what's the state of that? You know already, right? You know it's going to be subcooled liquid. Which of the following is the approximate amount of condensate depression? Oh man, it's easy. Okay. Condensate depression. Now, just so we knock it out of the park on this one, do above and beyond, what we're talking about is the temperature, specific enthalpy drawing. This is, of course, temperature, a saturation curve. And this is an isotherm or an isobar. Oops, sorry. Alright, so over here we have saturated. And then way over here we got superheat. Scratch that one right there. Dang it. This is going to be subcooled. Sorry. Alright. So at this pressure, this isobar or isotherm is going to be 1.0 psia. Right. If it was 10 psia, we would be up here. I think you all understand that pretty well. So at 1 psia, this point right here is the HF point. This point right here is the HG point. When the water or the steam or the mixture is at this point on the isotherm, and this of course would be saturation temperature, and that's 101.69 degrees Fahrenheit, we're saturated. Where was I going with this? When water's at this point at the HF, it is now saturated liquid, ready to start turning into steam. But we're at 100 degrees. So we are somewhere down here. Sorry. Okay. So we're here. In order to boil, we're first going to have to get to here. We're going to have to add some sensible heat to get us up to here. Alright, so condensate depression. That sensible heat that we're going to have to add, or that temperature difference, is going to be the condensate depression. Alright, so condensate depression, well, saturation temperature at a pressure of 1.0 psia minus the temperature of the condensate. Alright, condensate depression is equal to 101.69 degrees Fahrenheit minus 92. And that is about 9.69 degrees Fahrenheit. That is our condensate depression. Is that what the question asked us? I think it is. See, I didn't even read any of the answers. Alright. Condenser operating at 28 inches of mercury. Yeah, I got it. The condensate outlet temperature 92 degrees. Which one of the following is the approximate amount of condensate depression? 5, 9, 13, or 17. Well, it's about 9.69. But I'm going to give Mr. NRC man a break here and just say, yeah, that's right. Effectively, that's correct. All right, thank you. That's all I have to say to you people.